Hi, my name is Devni and I'm a software engineer at Rootcode Labs. And today we are going to talk about knowing vulnerabilities and what's out there for vulnerability management. So first of all, let's just define a few terms. What's a vulnerability? Simply saying, a vulnerability is a defect of a software that someone else can exploit. So how can vulnerabilities be introduced to your code? Well, let's look into your software. So there are components that you write from scratch, but it's not all of the code are not written by you. So you need help because you have constraint of time, resources, and other things. So what you do is you get help from other codes, and those are what you call dependencies. So you have the things that you write from scratch that maybe you can test and see that they are defect free, but there are dependencies that you borrow from somebody else that you need to make sure are vulnerability free as well. Because you can't always stay there and invent the wheel when you want to make a car. So you have to borrow the wheels from somewhere else, and there's no saying that the wheels that you invent yourself is better than any other wheels out there. So what we are going to do with vulnerability management is just making sure that wheel doesn't fall off when you're using the car in the future. So as I said earlier, when you have your own code, there are ways that you can use to make sure that it's defect free. It will start at the very beginning, at the design phase, using a secure design. And then, of course, there are tools like static code analysis, stuff like find bugs or Veracode or SonarQube that you can use to make sure that you are using the best practices that are out there. And then, of course, you can write test and have someone test your code. And then before you merge it, you have PR reviews from your colleagues that goes through your code and make sure there aren't anything known, any defects that are known in your code. So that's the code that you have written from scratch. But you need a similar process to the stuff that you didn't write as well. Because of course, dependencies that you use in a system. Maybe you have vetted from the start. Maybe it's the industry standard. Maybe it's the best thing there is, but there will always be problems in the future because we are always just one step ahead from an attacker. So in the case of checking for vulnerabilities in dependencies, you'd use a tool like OWASP Dependency Check. OWASP is the Open Web Application Security Project. It's an open source project where communities gather and create guidelines and tools for web application security. And the most famous one out of that is, of course, the OWASP Top 10 that talks about the vulnerabilities, the most prominent vulnerabilities in each couple of years. But they also have a tool called Dependency Check that you can integrate with your development and delivery, and that it will periodically check vulnerabilities in your dependencies. But it'll be good to know, how does OWASP Dependency Check know where does it know the vulnerabilities from? What list does it have? So it gets it from a place called the NVD, or the National Vulnerability Database. That's a US repository that contains all known vulnerabilities. So what it does is it keeps the publicly available vulnerabilities in a database, and tools like OWASP Dependency Check will be populated from that repository, and then it can use that information to check against the dependencies that you have in your project. And there are a couple of other acronyms that you must know, because when you Google, you will be overwhelmed with the number of acronyms out there. So let's just clarify a few of those before we go further into the presentation. So NVD, if I say NVD, that's National Vulnerability Database. And then there is another one called CWE, which just means the type of vulnerabilities. It can be something like cross-site scripting, or in the example given here, it could be hard-coded passwords, or where you check for a password entered by the user. You have hard-coded it into your code, and that's how you are checking the user password by a user. And it can be something like a race condition, which means you're not properly managing access to a shared resource in your code. And then there is the CVE. So CVE is the list maintained by a company called MITRE Corporation. So it started in 1999 as a effort to find out the vulnerabilities of software. So it maintains a list of reported vulnerabilities, and once they go through a process, they will publish that list into the NVD, and the NVD, from the NVD, other dependency check tools will get it. So that's how the process goes. With that said, how can you or someone, what if you found a vulnerability in a software? How can you report it? Is there a process like that? Yes. First of all, companies have disclosure policies. Each individual company has their own, but they are more or less the same. So, for example, a company like Google will even offer you rewards for reporting vulnerabilities. It can range from anywhere from $100 to $31,000. So if you found a really, really good bug, they will pay you for reporting it and not exploiting it. So there are eligible vulnerabilities from Google, such as cross-site scripting or cross-site request forgery or a server-side code execution, but they have also listed things that they don't consider as vulnerabilities. For example, if you have a blog and if you write a code to redirect a user from your blog to somewhere else, yes, it's a security concern, but Google doesn't consider it as a vulnerability. So you won't be getting rewards for those kind of things. But if you find a fault with Google, any of the Google domains such as google.com or YouTube or anything like that, you can submit that and get your reward. And similarly, Google has similar programs for Chrome and everything. And I have an example from a government site, US government site. They don't offer cash rewards, but they want you to report a vulnerability if you see it, because that's the best thing to do. And then, of course, when you're finding out, researching vulnerabilities, there are things that you can and cannot do. For example, you can't do anything illegal. You have to stop at a point where you know the next step will be illegal. So you can't go ahead and steal information and then go and report anything. So you have to be careful, always follow those rules. And one of those rules is you can't physically enter a building without permission and try some social engineering from like phishing attacks to a employee of that organization and get information from that. Those things are not legal, so you can't do that. But anything else, maybe you can change the URL of a website and gain access to somewhere you shouldn't be. All of those can be reported as vulnerabilities and nobody will sue you. So that is the vulnerability disclosure policy of each individual organizations. But let's look at how a vulnerability is reported to the NVD and how it finally ends up in that list. So first of all, suppose that this is you and this is the website that you always go to that has a top secret, like the world's best secret that you are not allowed to look at. So then just because you're curious, just because when someone says you can't do something, you want to do it. So you're curious, so you're just checking it out and seeing whether you can sneak your way in, not because you're a bad person, but because you're curious. And then somehow by chance or by sheer will, you go in and you see the secret. So now you have things that you are seeing things that you shouldn't see. But since you're a good person, you're not going to exploit it. You want to tell the people that are responsible that there is a flaw in the system and that other bad people can use it. So please go ahead and fix it while you can. So since you're a good person, what you're going to do is you're going to contact someone called either the MITA Corporation or a CNA. CNA is the CVE Assignment Authority. So those are like vendors or researchers internationally that are specialized in certain domains that will look at the bug that you report and check whether it's an actual vulnerability. They will vet it to see whether what's the vulnerability is about, how is it happening, how can they, and they will contact the vendor. So a lot of processing will be happening at a CNA. So what you will do is you will go to a CNA and then you will talk to the researchers there and say, I found a vulnerability in this site or in this program. This is what I did and this was the result that I got. And what they will do is they will use their expertise and see whether the vulnerability reported is actually something that can be exploited or not, and if so, how severe is it, how critical is it, and how many people will be affected, what kind of programs are affected right now, and who to contact regarding this. So they will, once they have vetted it, they will contact the vendor, and what they will do is create something called the CVE ID. So when you first report it, the CVE ID will be in the status reserved. And once the CNA vet the vulnerability and go through that process, the CVE will end up as a completed CVE with all the relevant information. And the vendor can request, can dispute your claim saying that this will never happen because of reasons like these. So in that case, then the CVE will be ended up as disputed. So once all that is done, the CVE will, and you can, all the parties has to agree that the CVE can now be published. Maybe the vendor needs some time to come up with a fix before the vulnerability is exposed to the rest of the world. So once all of that is done, it will end up in the NVD or the central repository, and from there onwards, it will end up in your dependency check. And the next time you try to run the dependency check, it will tell you are using a dependency with a known vulnerability, and there are ways that you can fix it, either by getting the newest version of the dependency that the vendor has put out, or maybe it's a patch, or maybe you can replace it with something else, or maybe there's something in the code that you can change. So all of that will be done, where that will be communicated first from the vendor side to their customers, and then to the world through the NVD. So like I said, Dependency Check is an open source tool that you can use. It will generate a report by scanning all the dependencies in your project. So in the first page, it will just list down the known vulnerabilities of a dependency, and then list the highest severity, so you can go through it at a glance and see whether it's something that you need to be concerned about or not. And then it will give detailed description on each and every vulnerability it finds. For example, here you can see this is a vulnerability reported from MySQL connector. This project, I just added a few examples of very old dependencies with vulnerabilities. So this is a very high severity vulnerability, and it will have information like the CVSS score, which is a score given to, is an estimation on how severe the fault might be. So what they do is use some vectors to score against. And so, for example, in this screenshot, you see that there is a vector called attack vector, which it has a value called network. So what that means is, where should the attacker be in the network whether they need to be physically available at the location, or they can be anywhere in the network, anywhere in the internet. So if they can be anywhere in the internet, of course, then it's very likely that this vulnerability will be exploited. So you need to fix that. So that has the highest score. There are other vectors like privilege required, which means how much privilege should the attacker have. Should the attacker be an admin or a super user before they can exploit the vulnerability, or can they be any old Joe? So this all factors into the score that is given as the CVSS score. So with higher the number, the higher the severity, and faster you need to find a solution for it. And finally, let's talk about GitHub Depend Upon. If you haven't noticed already, there is a tab called Security in the repositories available in GitHub. What you have there is an advisory. What they have there is Microsoft and GitHub has created what they call an advisory database, where they take information from NVD, but not only that, they use AI to go through codes in repositories and identify potential vulnerabilities as well. They have taken all of that information and put into a repository of their own called the advisory database. And what the Dependabot does is use that information and alert you when there are vulnerabilities found in those databases available in the dependencies you have in your project. And then on the last note, is relying on NVD enough? Of course not. As I said earlier, we are only one step ahead of an attacker at all times. Believe it or not, there are around 90,000 vulnerabilities that are in the CVE list that are not reported in NVD from its inception in 1999. So what that means is there are a lot of vulnerabilities out there that hasn't even been publicly known. And because of the aggregation process used by CVE, then there are issues that are repeated, issues that are not known. So what that means is basically that potentially attackers know information that you yourself doesn't know. So is relying on NVD enough to safeguard you and the dependencies from potential exploitations? Of course not. Since its inception in 1999, there are 90,000 CVEs recorded that have not ended up in the NVD database. So what that means is there are whole other information out there that might not even have a fix, but attackers have information on. So all those potential vulnerabilities that someone could exploit at any given moment. Not only that, informations can get leaked in other unofficial sources as well. Maybe a really kind-hearted person, just because it's something really proud that they did, have posted on Facebook, and attackers could see that information and exploit the vulnerabilities before a vendor could find a fix and release that fix to the customer. So what that means is you still need to have all those testing and all those best practices that you have, but dependency check is simply another tool in your arsenal in your battle against potential attackers. So it's a good thing that you can use, but it's not the only thing that you should use. So that's basically an overview about the National Vulnerability Database and how you can use it, and the components and the tools that uses the National Vulnerability Database to make sure that the dependencies that you use in your software is as secure as the code that you write on your own. So there are a lot more information out there about that. I hope this is the starting point that you can use to find other information about this topic as well. But thank you for listening. Bye.